This video introduces deep clustering for unsupervised learning. Clustering is a class of unsupervised machine learning methods, which categorizes samples with similar features into the same group. Unsupervised learning clusters samples based on their features without knowing their labels. Deep clustering combines a deep convolutional neural network and k-means for unsupervised learning in the end-to-end training. A trained deep network can be applied on different tasks, which is better than new networks. A network of deep clustering is obtained from AlexNet by removing the fully collected layers, and his output layer is connected to the last convolution layer. This AlexNet that is used to map input image to probability distribution over classes. By removing the fully collected layers, we get a network for deep clustering. This modified network maps the input image to visual feature vector. By using visual feature vector, k-means clusters the input image to the correct group. A function f-theta maps the raw image to a feature vector with fixed dimensionality in latent space, where theta is a network parameters. Given a training data x of n images, the goal of deep supervised learning is to find the optimal theta, by which f theta generates the good general purpose visual features. The parameters theta are learned using supervised learning through paired input xn and label yn, where k is number of classes. A classifier GW with the parameters w predicts the correct labels using the visual features f, theta, xn. Parameters w and theta are trained jointly by optimizing this loss function as shown here. Where L is a negative log softmax function, mini-batch SGD is applied to minimize the loss function through backpropagation, and the gradient is applied to update the model parameters W and theta. In unsupervised learning, k-means is used to cluster outputs f theta generated by the deep network to generate pseudo labels of input samples, which in turn are applied to train the deep network in the supervised fashion. If k-means clusters samples in training dataset into k distinct groups based on a distance criterion, we learn a D by K centroid matrix C, where D is the dimension of feature vector in the latent space, and K is the number of clustering groups. And the cluster assignment Yn of sample xn by optimizing this loss function as shown here. Solving this problem provides a set of optimal assignments and a centroid matrix C. These assignments are then used as pseudo labels. Deep clustering alternates between clustering features to produce pseudo labels and updating the parameters of the deep network. Normalized mutual information is used to measure mutual information between two assignments x and y in this equation, where h is entropy, b is probability density of xi. Mutual information function I is defined as here. If hx and hy are independent, the joint probability of xi and yj is equal to product of two probabilities. and I is equal to 0. Otherwise, if Y can be predicted from X, I is equal to 1. The best accuracy is obtained at K is 10,000 on ImageNet. For more details, please check with these references. Thank you. Bye.